So I'm Josh Berkus.
Praveen Kumar.
Yep. And among a variety of things, we both participate in the BootC project. So we're going to talk a little bit about that and why we're excited about it, and why we hope you'll be excited about it, and what we use it for. So I mentioned that I was going to talk a little bit about ancient history in this talk. And I'm going to talk a little about ancient history so that you will understand why BootC is important and why we are so excited to have it ready to use. So I mentioned that I started with Linux in the 90s. And one of the first things you did with Linux distros, you're working with Slackware, et cetera, was you literally compiled everything. I compiled the kernel, I compiled all the applications from C code, compiled the graphical operating system, and if you think Kubernetes is a hard build now, it's nothing on, X Window Maker. So trying to build all that different stuff. And so we all decided that that actually kind of sucked, and it took way too long to build anything or to update your system. So by 2001, with Red Hat Linux and SUSE Linux out in the field, we'd moved to the system of operating system packages. RPMs, later on deb packages came along, right? And so these were pre-compiled application binaries that you could use so that you weren't compiling everything yourself. And that was a huge improvement. However, managing all these packages became its own problem. And so a bunch of people put together what's known as config management, right? And originally the main purpose of config management was simply to manage all the packages you're installing, right? And how you're installing them, what their settings are. And so you have all of this stuff. And we got Puppet and Chef and that sort of thing to manage all of that. And that was definitely better, but it still wasn't quite good enough because the config management had to do a whole lot of work. Keep going. And there were a bunch of problems with this that were chronic problems that all of you folks who are admin or DevOps will recognize, right? Which is, once you got to a large number of machines, right? If you were trying to deploy 100 new machines at once, which was a lot in those days, it took forever. A certain number of the machines would just end up configured differently or would fail to install for mysterious reasons. Those failures were not self-correcting. Some administrator had to shell into them and spend a long time figuring out what went wrong and undoing it. One of the reasons that this was really, really slow is that it didn't parallelize very well. I don't know if you remember early versions of Puppet and Chef were strictly serial, and even later on trying to do it massively parallel. And one of the biggest things that was a problem is no rollbacks, right? If the system failed to install or failed to update, then you were taking it out of service and actually doing an overhaul because you couldn't revert back to the last good state. So then cloud came along. And one of the things that we got with cloud, which was built on virtual machines, I mean, this actually happened before cloud with VMware, right? But then it really got going with cloud and with Amazon and stuff, was the idea of deploying images. So instead of having your sort of base operating system as one binary and having a whole ton of other binaries that you install on top of it, we have one image that we put together that has almost everything that we want for whatever system we're deploying, right? You would define that, and the advantage of that is you define that once, and then you could deploy it multiple times, which was awesome and was a huge improvement, and suddenly deploying 100 systems seemed like nothing at all, and we started deploying 1,000 systems. Next. However, this still had problems. One is the tools for creating the images themselves were really annoying and hard to use, and really, really slow. The virtual machine images were huge, so moving them around, copying them, updating them was, again, really slow, really annoying. This whole cloud approach worked great on public cloud, but was really difficult if you were deploying it on your own metal. You had to build a whole bunch of infrastructure, deploy an OpenStack cluster, everything else, to have any chance of making this work on your own metal. And we still didn't have rollbacks. So then this thing came along, actually in 2014, but I really started using it in 2016. Container images, right? And these were for applications, right? And suddenly the idea of, hey, we're not just going to install the base binary for the application, but we're going to actually give you the entire application as configured with its dependencies as one binary in a container. And this had a lot of advantages because the build tools for container images were a lot simpler and easier to use and integrated well with tools developers already used. The images were smaller and they built faster. You could deploy them either to bare metal or cloud, wherever you wanted to. And importantly, for those container application images, you had rollbacks, right? Because if the new image didn't install, you could roll back to the previous known good image. So we had rollbacks here. And that's where BootC comes in. So the idea of BootC is, let's take that application container principle and apply it to the entire operating system, right? Take all those advantages that we have for application containers and apply them to installing systems and not just applications. That is the advantage of those containers are a lot easier to manipulate and move around. The BootC application and system manages that for us, right? It helps us build those bootable container images. It helps us deploy them to system images. It helps manage status and updates. And importantly, it supports rollback. So everybody here is familiar with application container images, right? So, got this whole concept of you got the app and that sort of thing, but it's running on the base kernel. So if we want to deploy a system, we need to make a slight change to the image. And of course, it's actually a big change to the image, which is we need to actually put a kernel in the image so that it's bootable and it can run itself. But otherwise, it looks just like an application container. It's a big tarball with metadata. It just happens to have a kernel in it in addition to all of the user space code. So, with that preface of what we're doing and why, let's actually show this off.
Now?
Yeah, there you go.
Okay, thank you. So, because most of the time, live demo doesn't work, so I just recorded it out. And then we will actually go in details like how the thing's working. But the idea is the same. We want to showcase how in the operating system side you can use the same concept as we are using till now in the application container, where you specify your image as part of the container file, and then you create the container out of it, then distribute that image to a registry. Somebody wants to try out, they can use that registry and then try it out. And for that purpose, I'm going to use something called Podman. Anybody know Podman here? How many people are actually used it? Nice, thank you. And how many people know about the Podman Desktop? How many people? Oh, nice. I want a picture of it. Okay, so we are going to use those things. Why we are using it is I'm using Mac right now, and you already know that by default, recently Mac started a project, but it's still not in mature state. But before that, you can't build a container image directly on Mac. You need a VM. Even Docker use behind the scene VM, which you can create the container image out of it. So let's see if is it font is okay? At the back, if people are not able to see it, okay, it's good enough. Thank you. And I can't make it more bigger. So this is the Podman Desktop dashboard. And I have running the latest and greatest version of that. The thing is that I have installed something called extension, and in the extension, I have this extension called BootC extension, which is I'm going to use during the demo. All the extension, you can install it. There is a very nice README files on the Podman Desktop documentation side where you can go and check. At the end of the demo, everything which we are going to showcase is on GitHub. So please do check out, and if time permits, make sure that you do kind of a hands-on around it. So you just need to follow the steps, and you are able to do, their first bootable container, and then you can easily deploy it and then do whatever the imagination takes you there. Okay. So with that, let me start with this particular coding. Think. Okay. So as we said that everything is in the container file. So the way we want to create the image, the BootC image, I would say, the details of the image, the specification of the image will be part of this container file. So here you can see what I'm doing is that it's a very plain container file which you use, I think, day to day to create your containers. So we are setting the repository. The first thing you can notice is that if you go on the top, the first thing is the BootC, Fedora BootC. So this is a specific container which contains the Linux kernel of the Fedora also, because we are going to showcase the BootC part. The labeling we are doing like we are doing for the container file. We are setting up the Kubernetes repo. To set the context, what we are trying to do is that we want to have everything as part of the Kubernetes controller as a BootC image. So once we build this image, and when I try to deploy that image as part of the VM, and then automatically the Kubernetes controller is supposed to be up and running, and all the pods are supposed to be up and running without me doing anything manually. And then after that, we are going to showcase the update parts and the rollback parts also. So yeah, these are the basic things. I'm going to install the packages. I'm using the RPM OS3, but you can use the DNF install now, because it's now the BootC image have the DNF also. So you can use the same, your old image if you have, and then you can actually convert it to the BootC image also. So this is the container file. Now go to Podman Desktop. I try to build that image using that particular container file. So I build it. I give the container file path, which I have here, and it will automatically take my build context directory where I'm supposed to build, and the image name I give. I already have the image, so I'm not going to build it here. You can see I have these two images. One is tag 1.33, and the other one is the latest one, because I want to showcase the update and rollback. So the latest is right now is Kubelet or Kubernetes version 1.32, and I have the 3.3 also. So how it automatically updated to 3.3. So once I have the image, and then I go to that particular extension, bootable container extension here, and the image listed here are the BootC images only. So I choose the latest one, and I'll say that, okay, I need a disk image out of it. So what it do is that if you see here, sorry. I want to just highlight how we are actually creating the disk image. So yeah, so we can choose any BootC image. Right now we created this KubeCon demo image. And if you can see what kind of a disk image type you want to get as outcome. So you have the option of raw disk image. You can even convert it to AMI and directly upload it to your AMI on Amazon. You can have the QCOW to use the libvirt, and you can have the virtual hard disk, and then you can have the Anaconda ISO and the GCP image and all those kind of things, right? And then virtual image, disk image, which is you can use with the Windows. So I'm using the raw because on the Mac, I can directly start the VM using the raw image. So I gave the image, and then I tried to use which of the output directory I want to use where the disk image is supposed to be present. So I choose that. I am choosing the raw disk image. The platform, yes. So here in the Podman Desktop, you can actually even, I have the M1 series, which is ARM-based, so you can even use same thing with if you want to create the image for x86 and 64 also, which is Fine. And then I'm going to use a build config file. So build config file in the BootC side, it's a very simple file where you can actually consume, like, you can put like, okay, which user I want to create, what is the password, what is the key of that user. Yeah, anybody use cloud init, it's kind of the same things like, okay, before creating the disk image, I need to have access, way to access that particular running VM. So I put all those details in that. So I put the very basic thing like added user to the wheel group, have the user as a core, and all those kind of things. So, and then I'm going to build that image, and it takes some time, but it's built successfully. Once I have that image, you can see it's listed in the disk image side, and I can run it, and it will create a virtual machine in my Mac. I use the username as core because I set that as a core. And then I have the virtual machine up and running. And you can see that where it is in the, there is another component called BootC VMs. You can check the BootC VM, and you can see if it is, you can just start it. On the top, you can see it's starting, and just after some time it is running. You can even get the console. So I SSH to that VM, which is still running locally. And then the first thing we will try to do is that try to see what is the current status of our VM. So you can see here, since we booted from, so if you see now, since we are booting from an image, it is very, very easy to, you know, kind of put another layer of a different image so that the update will be very easy. So now, right now, it's this is the current status because I use that image. And then this is the tags I have on my QA side where I put this 1.2 to 1.33. So now, just to showcase what is the current version of in the VM of the kubelet. So you can see it's a 1.32, that's what we used. And then the next thing which we will try to do is that we also try to see if everything is running. So if you can see, I didn't do anything, no configuration, and every ports and everything is already running. So it's like, this is kind of, you can say, golden image. If you want to distribute internally, you can give it and people can directly consume it and then just start using it, right? And it's not like it works on my machine and it's not going to work on yours because everything is in the specifications in container files, and then you can just give it. It's the same thing like the container ecosystem actually changed. So now what I'm going to do is that I'm going to do BootC update. So how it is actually able to get the image, because I have two different tags already. The latest is going to point 1.33, and my image is actually always checking the latest tag. So if anything change happen in the latest tag, it's going to pull down the latest tag again and going to update it. So it's apply the updates. And then we again check the status. You can see what happens is that it's not like as soon as you get the update, it's going to be applied as soon as possible. But what it does is that it stays the image first, and it will give you the information that this is the stage image, this is the updated image. If you want to use that image, you have to reboot it. Otherwise, you are still going to use the same one. There is another option called apply, where it will not show like there, without the user interaction, it will automatically update the system. So now I'll just need to reboot the system, because then how it will going to be apply the updates. And then when I again log back in on that VM, and I'll try to see what is the status of the BootC right now. You can see I'm going to have the new version of the image, the booted one, which is going to be different digest. And I now have the present of the rollback image. So what happens if I somehow the current system is not even coming up? So it will automatically go back to the rollback one and make sure that it's up and running. So again, I'm check what is the version of the kubeadm, kubectl, whatever it is, whatever the Kubernetes package I have. And you can see now I already shifted to 1.33, right? And you can check even the ports also, which is already running. So you are actually kind of migrated from one version of the Kubernetes to another without disrupting anything. Only the disruption is the reboot time which you have, which is kind of a minimal. So yeah, you can see the ports are running, everything is there. And now the next thing is the rollback, which is also quite easy. Now assume that we are trying it out like 1.33, they have the issue, and now we want to kind of meditate that, then what we can do, we can roll back that particular previous version, which have the 1.32 image. So it's, again, it's very simple command. We roll back it, and it says that next boot, you have the rollback image. So you can see it's a rollback image is already there. And then when we reboot it, it will be going back to the rollback image. So yeah, so just after the reboot, SSH, I again tried to check the kubectl version. You can see it's back to the 1.32 where we are started. So that's how this is the end-to-end kind of a demo purpose where we showcase how the things actually working with the BootC. So we had a container file. We created a build using the Podman, and we have the bootable container image, which has the 1.32, right? Then we converted it to the disk image. We deploy it using the VirtualBox, but that deployment can be anywhere. You can have the deployment on any cloud providers. Actually, from build to converting the image, the disk image, you can convert any type of image you want. And then what we did is that as part of the update, we again build a container file, which has the newest version. We push back to the container registry. We use the BootC update command, and you have the latest version, right? And the rollback is we actually did the rollback command, and we have this container registry, and it is back to this.
Yep. So if you want to try that out for yourself, there is the link to Praveen's repository, where he has all his scripts that he used for that demo, for you to go ahead and try out.
And if you want to use in the CI/CD way, like you don't want to use in your laptop and all those kind of things, in the same repository, we have a GitHub workflow file where every PR which I'm putting in there, it actually creating end-to-end the new disk image, the new container image, which is the bootable container image. And if you check the packages there, you can see that there are already images which are present when I started this particular.
Yeah, so you can see, so the advantages here for BootC update is you aren't choosing individual components or choosing to install or update individual packages and that sort of thing. One thing we couldn't really demonstrate in this demo is we had some interns, I think it was, who actually worked on algorithmically making the image layering super efficient, so that those updates change a minimum number of bytes for an average system. And so it's a very efficient way to update the systems. There's no possibility of getting a partial update, right? There's no possibility that we might say, install the 1.33 version of the kubelet, but still just 1.32 version of kubadmin, and then have that particular node not function. It can't happen. And if the update fails for some reason, it rolls back, right? If it won't start up, it automatically rolls back. If it startups and doesn't function, you can roll it back with one command.
So you are mostly updating it like you update your phones, right? You have update, you click on update. What it do is mostly it's get the image, which is the layered image, and it update it. If it is not, doesn't have issue, it roll back to the previous one.
Yep, so the next thing for you to do is to try out BootC for yourself. The easiest way to get started with BootC is through Podman Desktop. So you install Podman Desktop, which is available for Linux, Mac, and Windows desktops, and install the BootC extension, and then play around with creating your own system images and trying to deploy and bootable images and trying to deploy them. It's really easy.
So in Podman Desktop, we have some of the kind of learning documents also. You can follow step by steps to get the the BootC images.
Yep. And then the other thing to do, obviously, is to join our community. This is an open source project. So we want you to participate. We want you to try it out in your environment. We want you to give us feedback. We want you to file issues when things don't work. And of course, if you are prepared, we want you to contribute to the project, right? So not just bug reports, but testing on different platforms, helping us with documentation. If you write Go code, contributing directly to BootC itself. We can use it all. So just go ahead and leave that up because we actually have a few minutes for questions. So, questions?
Yeah.
Already we have the rollback and all features in the Kubernetes images itself. What is the difference between adding the Linux machine into the application itself? It won't get more load as far as the OS is concerned.
Sorry, which project are you talking about? In the Kubernetes?
BootC.
No.
Kubernetes already having the auto scaling and rollback update, everything we are doing.
No, it's so you are talking about like
containers application.
Yeah, so container rollbacks is a different. Here we are talking about the complete operating system's rollback. It's not only the one component which we are rolling back. It's complete operating system going to the. So assume that you have a package like any dependency which you have, and if it is going to conflict with other dependency, you have to manually roll back that dependency right now. Otherwise, you are not able to do it. On the system side, on the OS level side, not on the Kubernetes side.
Okay.
Yeah. Yeah.
Hello. Can you run a complete operating system, including graphical user interface and stuff like NixOS similar? Or, yeah, like, can I use it for my day-to-day usage?
I think the echo is there.
Yeah, so
Yeah.
actually the project to look at for that is Bluefin Linux, which is what I actually use on my laptop. And that's a desktop operating system based on image updates, etc. And the important thing for this for desktops is it makes it very easy to create forks. So like I run called Bluefin DX, which is designed to be a developer desktop with a lot of tools in it for building application containers and stuff.
We have a question.
So
back
yeah,
here.
we had.
So when you build that image, exactly what you use for the Kubernetes? Is it kind K0, K3s, or it is full-blown Kubernetes with all the storage providers and all?
So right now, the way I'm using it is mostly the RPMs of the Kubernetes, no kind, nothing as of now. So it's a basic packages which I'm using on top of my Fedora box to create the image out of it. And that's it. So once you have up, you have the host is Fedora, and then you have the Kubernetes package on top. Yeah.
Hello. Is there a CentOS BootC image?
They have.
Also, how does it work when we have some cloud dependency? For example, when we built our AWS AMI from CentOS, we have some NVMe init script which would mount NVMe, which runs sometimes before cloud init, then we restart kubelet and all those things. How does that come into picture when we have?
So you can actually, so it's a container image. Your cloud init file, if you really want to have, you can actually make it as part of that container image itself. You can kind of add to that image. So as soon as you create the AMI, it's already have that particular cloud init file. You don't need to pass the metadata. So all the things which you required is part of the.
And when we build incremental builds for AMI with BootC, is that builds also faster? Because like the updates change, like we were changing the kubelet or Docker runtime version. So when there is a new image creation, is the new image creation version also faster with BootC?
So new image, you mean the BootC image which get to be updated on the AWS side?
Yeah, to the AMI.
So, yeah, so that whatever the layer is supposed to be, it's going to be updated. Only the /etc part, I forgot to mention, it's an immutable system. Only the /etc part is what is going to merge. So your configuration, which is already there, that's not going to change, but your packages level and all those dependents going to be updated.
So one more question back there.
Hi.
Hi.
You have explained about single node. So how it work for data plane as well as a worker node? How do you have some automation where or some kind of setup where you can upgrade both together, because you can't just upgrade one and it will break the dependency. So you have solutions for that?
So right now, this you can see this is an image, right? I'm just showcasing on the single node, but this is a container image, right? So how you are right now orchestrating a single container image to the multiple way, the same way you can do it here. You can build your own CI pipeline where you can mention, okay, these are the hosts which are using. I just need to be if I build an image, like I have a gold image, assume that with version 1, and I create a version 2 image. Now I want to update all my fleet onto version 2. You can just use any other toolings which can actually execute all your nodes, this BootC update, and it automatically update all the components, all the VMs fleet to new version 2.
So my question was something it has SSH enabled. So do you have Ansible script where all the bootcs will boot to upgrade together or something, so that we have minimal downtime where all the nodes will come up at the same time, something of that sort. Like all the upgrade as well as rollback will be in sync.
Yeah.
Can I have? Yeah, so for your infrastructure, you don't actually want them to go all at once. You want to do a rolling update, right? And so this would be part of a rolling update, right? Where you take down, because when you take one down, any workload that's running on that one, right? Even if it's just a very quick reboot, any workload that's running on that one's going to stop, right? And so you actually want it to be part of your automation where you say drain the node and then update the node, and then drain the next node and update that one. Okay, and we are out of time. So if you have further questions, catch us out in the hallway or obviously on Slack, BootC channel on CNCF Slack. And thanks very much for coming.